Hello everyone. In this lecture, we have discussed on the factors affecting the SN1 and SN2 reactions. They are the five factors which affects the SN1 and SN2 reactions. The first factor is nature of substrate. First factor is nature of substrate. Second factor is strength of nucleophile. Third factor is concentration of the base. Fourth factor is nature of solvent, and the last factor is nature of the living group. So let's see in details the factors affecting the SN1 and SN2 reactions. The first factor is nature of the substrate. When we go from the primary to tertiary halides, primary halide to the tertiary halides, primary, secondary, and tertiary. Primary, secondary, and tertiary halides. The stability of the corresponding carbocations also increases. The stability of the corresponding carbocations also increases from the primary to tertiary carbocations. Means we know that the stability order of the carbocation is the tertiary carbocations, which is a more stable than that of the secondary and primary carbocations. So the tertiary halides is a more stable than the tertiary carbocation is a more stable than that of the other carbocations, so that the tertiary halides would prefer the SN1 mechanism. So the tertiary halides would prefer the SN1 mechanism. The crowding takes place, the crowding of the alkyl groups increases from the primary to tertiary halides. The crowding of alkyl groups from primary to tertiary halides increases. Hence, the attack of nucleophile is hindered sterically when the alkyl groups, when the crowding of alkyl groups increases from the primary to tertiary halides. Hence, the attack of nucleophiles, hence the attack of nucleophiles is hindered, sterically hindered by the alkyl groups, because here the sterically crowding of alkyl groups. So the attacks of nucleophile on the carbon atom is not, that is a possible, because the more steric crowding takes place adjacent to the carbon atoms. Hence, the SN2 type of mechanism can take place in primary alkyl halides. Means SN2 reaction, SN2 mechanism takes place in the primary alkyl halides, and SN1 reaction takes place in tertiary alkyl halides. Means SN2 reaction favors the primary alkyl halides, and SN1 reaction is favor the tertiary alkyl halides. Now, the second factor, the strength of nucleophile. Strength of nucleophile. In SN2 reaction, the attack of nucleophile on the carbon atom takes place in the rate determining step. In SN2 reaction, the attack of nucleophile on the carbon atoms takes place in the slow step or rate controlling step. Hence, strong nucleophiles are favors the SN2 reaction. Strong nucleophiles are favor the SN2 reaction. In SN1 reaction, the nucleophiles reacts with the carbocations only in the fast step. In SN1 reaction, the nucleophile reacts with the carbocations only in the fast step. Hence, the weak nucleophile favor, hence weak nucleophile like the water can also results in the SN1 reactions. Means strong nucleophile favors the SN2 reaction, and weak nucleophile favors the SN1 reaction. Now, third factor is concentration of base. Concentration of base. With increase the concentration of the base, with increase the concentration of the base, the probability of attack of the base on the carbon atom increases. When increase the concentration of base, the attack of base on the carbon atom increases. The probability of attack of the nucleophile on the carbon atom increases, and hence the SN2 reaction is favored. SN2 reaction is favored. In SN1 reaction, the nucleophile is a reacts with the carbocations, and hence the low concentration of the base favors the SN1 reaction. Means high concentration of base favors the SN2 reaction, and low concentration of the base favors the SN1 reaction. The next factor is nature of solvent. Nature of solvent. Now, the polarity of solvent has a mark affect the mechanism of the reaction. The polarity of the solvent has a marked effect on the mechanism of the reaction. The SN1 reactions involves the formation of the carbocations. The SN1 reaction involve the formation of carbocations. The carbocations means carbon carries a positive charge and which can be stabilized by the solvent to the solvation. The carbocations which can be stabilized by the solvent to the solvation. What is the solvation? Solvation means the nucleophile, that is a solute, is a surrounding by the solvent, or a solvent is a surrounding by the solute particles. Okay. Now here the carbon carries a positive charge. Okay, they are the CH3 here, CH3, 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 and then the carbocation is a stabilized by the solvent. Means here you take the water molecule. Water, oxygen carries a lone pair. That is a partial negative charge. Here also the water. Okay, water. You write the water. Here also the bonding between the carbon and the oxygen. Means the carbocation which can be stabilized by the solvent to the solvations. Okay, and hence the more polar solvent favors the SN1 reaction. And hence the more polar solvent favors the SN1 reaction. Whereas in SN2 reaction, there is a dispersal of charge in the transition state. Already we have seen that in a SN2 transition state of the SN2 reaction, there is a dispersal of the charge in the transition state. This negative charge is present on the hydroxide ions and as well as on bromide ions. Okay, and hence the less polar solvent are sufficient for the SN2 reaction. And hence the less polar solvent are sufficient for the SN2 reaction. Means the more polar solvent, okay, more polar solvent favors the SN1 reaction and less polar solvent favors the SN2 reaction. The last factor is nature of the living group. First of all, what is a living group? A group which is attached to the substrate. A group is attached to the substrate which departs or leave along with the electron pair. A group is depart or leave along with the electron pair from the molecule is called as a living group. For example, the carbon bromine. Okay, the bond between the carbon and bromine. You take the any one example, CH3Br, suppose H hydrogen and also the CH3Br. Okay, methyl bromide. Then the bromine is attached to the carbon atoms. Carbon carries a partial positive charge and bromine carries a partial negative charge. Okay, now the bond is a break between the carbon and bromine. Okay, now the bromine carries a 3 lone pair of electrons. Okay, the bromine carries a 3 lone pair of electrons. When this bond is break, this living group, okay, this group, when the leave or depart along with the lone pair of electrons, and also the negative charge is present. There are the 3 lone pair is present on the bromine and also the negative charge. Okay, this is called as a living group. This is called as a living group. The nature of the living group also decide the mechanism. The nature of the living group, the nature of the living group also decide the mechanism. There are the two factors important to decide the living group. The first factor is a basicity. Basicity, okay. The basicity is one of the factor, that means weaker base, weaker and the stronger base. Okay, now here the weaker base is a better living group. Weaker base is the better living group. For example, halides are the living group. All the halides are the good living group. All the halides means fluoride, bromide, chloride, iodide. Okay, these halides are the good living group, as because they are the weak bases. Because they are the weak bases. The other factor is the size of the group. The first factor is the basicity. The all the halogens are the weak bases. Okay, so the halides are the good living group because they are the weak bases. Okay, because they are the weak bases. The other factor is the size of the group. Other factor is the size of the group. The larger group will be the better living group. Larger group, larger size group will be the better living group. Among halogens, iodine is a larger size. Fluoride, chloride, bromide, and iodine. Okay, iodine is a being the largest, acts as a better living group. Iodine is a largest, acts as a better living group. Means when the fluorine, chlorine, bromine, and iodine has a larger size, so the iodine is a better living group. Okay. The OH group is not a good living group. The OH group, hydroxide ions, is not a good living group, but the aryl sulfonate has the larger size. But the aryl sulfonate means OSO2AR. Okay, O, yes, double bond O, yes, double bond O, double bond O, AR. Okay, this bulky group, okay, larger size group is excellent living group. This aryl sulfonate is an excellent living group, but the OH group is not a good living group. A good living group favors the SN1 reaction. A good, sorry, SN2 reaction. A good living group is favors the SN2 reactions. Means nature of the living group decide the mechanism. There are the two factors very important: the basicity and the size of the living group. The weaker bases are the better living groups, and the larger size of the group will better living groups. Okay, so iodine is a larger size group, so iodine is a better living group as compared to the other halogens. OH group is not a good living group, but aryl sulfonate is an excellent living group. A good living group favors the SN2 reactions. So today we stop here. Thank you.